The final presentation of the conference, Daniel Silevi, is that right?
Yeah,
close enough. We'll talk about 5G media streaming and 5G broadcast.
Okay, perfect. So I try to keep it short, last presentation of today. So my name is Daniel Slavi. I'm with Fraunhofer Focus in Berlin. I'm going to talk about 3GPP Release 17, 5G media streaming and 5G broadcast powered by the 5G MAC reference tools. A few words about 5G MAC. So 5G MAC is short for 5G Media Action Group. It's actually multiple companies and stakeholders coming together, working on open source tools for 5G media. The development and the whole work in 5G MAC is really community and member driven. So you have these companies coming together, as I said, and they work in different working groups. And what we will focus on today is the working group number 4, where we actually work on reference tools for 5G media. So what do I mean by reference tools? So basically we are taking the 3GPP specifications and we are implementing reference tools on top of that. We have an open community of developers. You can see the list of the official contributors on the bottom of the slide. So we really have already multiple companies working on these kind of tools. And the important part is that this is really a reference implementation. So our main focus is on, as I said, taking the specifications and doing some reference implementation on top of that to provide feedback to the standardization experts. And I always highlight that in my talks. So we have really kind of a feedback loop in place where we talk directly to the specification editors and we provide feedback, but at the same time I'm in a very good position as a developer because I can directly reach out to the experts and ask questions if something is unclear. So we kind of benefit from each other. Another thing that I wanted to highlight is that we really have an IPR-friendly licensing model in place for 5G MAC. So you see some of the big players here on the bottom. So you can really come and contribute to the project, even if you're a bigger company. For the development roadmap, we actually had a program called Target 2023, where we first had a start-off call, more or less, where we had 3GPP SA4 experts introducing 5G and 5G media-related specifications. And based on that, we asked the community and companies to come up with use cases around these specifications. And we collected over what was around 30 use cases that we then discussed internally, and we came up with a prioritization and some overlaps also between these use cases. And I would like to point to the paper for more details. So these are the use cases that we identified as the most important ones, but also taking into consideration where we have actually development resources available. What I highlighted here are the more or less main topics that we will also focus on today, which are 5G media streaming and 5G broadcast. So we have really lots of overlaps between these use cases, and we try to set the baseline or the foundation where people can take the reference tools and build their own solution or build additional use cases on top of that. I want to start off with 5G media streaming, and when I say 5G media streaming, you might ask yourself, okay, but this is something that should work out of the box. So I take my mobile phone, I connect it to a 5G network, and then I start streaming. And basically, you're right. So the architecture of this is more or less depicted on this slide. So we have a content application provider providing content with Dash and HLS format, typically used with the CMAF container. Then you have a CDN where your files are located, and they are delivered via the core, the 5G network, 5G radio access network via unicast to the end user app. 5G media streaming is really, the idea behind that is to put media streaming specific components into the 5G architecture. And what you can see here color coded in yellow are these components that we added more or less on top of the existing architecture that I just explained. And I want to highlight, and we have seen this previously also in Emet's presentation, that we have on the core side 2 new components, the application function and the application server. And the application function is really the component that holds the main logic. So it's located in the control plane. It has an interface to the application provider. And basically using this interface, you can define the content that should be hosted and played out. You can define metrics that are supposed to be reported from the client side, consumption reports. And where it gets really interesting is the part where you can provide network assistance. So you can basically allow clients to ask for a network boost, if they are in a situation where they might run into an empty buffer, but also you can provide additional information to the clients via the application functions, such as the current throughput or the maximum bitrate that the client is supposed to use. So we already have some overlaps here with CMSD and SAN shared resource allocation. On the client side, you have this media session handler that communicates with the application function, and that is responsible for reporting metrics, for reporting consumption reports, providing or asking for network assistance. So you really have multiple components on top of this, let's say, dump bit pipe that I showed you before in order to enhance the streaming experience. So this was 5G media streaming. Another thing is 5G broadcast, or also labeled LTE-based 5G broadcast, where you basically use the 5G network to broadcast your content to the end device. This can be done using the 5G network, but also an LTE-based network. And basically, as I said, you broadcast the content to the client device. You have a broadcast receiver, which is called MBMS client. And typically, you put the files that you received on a media server, and from there, they can be played out traditionally in your application. So for the broadcast delivery, you typically use a protocol like Flute or Route in order to package your content or pack your content, pack your dash and HLS segments into this broadcast stream. And if you're completely crazy, then you combine those two worlds. So you combine 5G media streaming and 5G broadcast. And nevertheless, what you get from that is really interesting, because think about different use cases. For instance, you deliver your content via 5G broadcast, and at the same time, you allow viewers to do time-shifted viewing, or you enhance the viewer experience by offering additional languages, additional subtitles via unicast, or you even replace broadcast ads with broadband ads. So you kind of get the best of two worlds, and this is what we are working on in the 5G Mac reference tools, setting up components, repositories for 5G media streaming, for 5G broadcast, and then combining those in order to enable additional use cases. This is what we have in place currently, and again, you see these different colors here. So different repositories and components corresponding to the 5G media streaming architecture. And then for the LTE-based 5G terrestrial broadcast part, we also have components available on our GitHub. I don't want to go through them in detail. You see there's a lot of stuff going on this slide. I encourage you to check out the GitHub repository. There are end-to-end guides explaining how to set all of this up. I want to highlight that we do not start from scratch. So we are also relying on other open source tools such as Open5GS for the core part, or SAS RAN, also offering a core, and with the latest release, more or less focusing on Open RAN on the RAN part. So we're really not starting from scratch, but relying on existing open source tools. And then I have one very short demo video for you that we recorded. So this is demonstrating how 5G media streaming looks more or less in practice, and I'm filling my Linux screen here. So very quickly, I'm starting up an application server to host our content, an application function to manage the content, and then I'm using our internal REST interface to do all the necessary configurations, basically providing like one endpoint, which we will see later on in the streaming part. There are actually lots of interfaces in the 5G media streaming architecture. One thing that I'm highlighting here is the so-called M8 interface, which is application-specific, where you get some metadata in order to initialize your application. And then on the client side, we develop multiple Android applications and also libraries that do all the communication between client side and core side. This is again done via different interfaces. There's a lot of stuff really going on, but in the end, unfortunately, the only thing you see is a video playing. So it hides a bit the complexity that is underneath. But as I said, having these dedicated components really gives us additional complexity, or takes away the additional complexity that you get from enabling broadcast, unicast, and also stuff like metric reporting, consumption reporting. If you want to get involved, we actually have a Slack channel where you can participate. We have a Google group available where we do release announcements and also announcement of release candidates. We have internal and public calls that you can join, and everything that I just explained is available on GitHub. So you can try it out right now if you want to. Probably you don't want to try it out right now, but maybe after the conference. And otherwise, we're happy to take questions as well. And as I said, I'm going to be quick, so that was all I had. probably no questions anymore, but yeah, if you want to reach out to me, you find my details also on the slides. Thank you.
Thank you very much. Questions?
Yeah, thank you for the presentation, Daniel. Question, you put some of the segment and MPD server in the 5G network as a function. So is there any accommodation, for example, when you switch your mobile phone from mobile to Wi-Fi or something like that, so that you can keep playing the video, or is that affected, or is that
it shouldn't have an effect. So you contact this application server that basically hosts the content normally via the internet. What you get from the 5G media streaming architecture, or what you would lose if you switch to Wi-Fi, is really something like this network assistant feature, where you can ask the application function for network boost for additional information. But for plain playback, that shouldn't have an effect if you switch between those different networks.
Thank you.
So I have a question. How prevalent deployed is 5G multicast? Can you give examples or tell us about?
So I know that, for instance, ORS is doing some stuff around that. And I know that there are some, let's say, joint demos between ORS, for instance, and Qualcomm with some, let's say, special devices or devices that are not out there yet, where you can have like native support for 5G broadcast. And they would operate in, it's called receive-only mode. So you do not need to be connected to a mobile network. You can simply receive everything, even if you're not connected to an MNO. But I wouldn't say that this is really widespread at this point. So it's really more or less work in progress to get this more populated. Yeah.